Hello, I'm back. So, hi guys. I think now today this will be the officially it should be the third part, but as in our last second lecture it got extended, so the alignment part was covered in the 2.1. So today will be the third part of it, and like till now what we have done was to understand the different methods and algorithm to do it. And today, like in previous lectures, you might have heard me talking about this is bridge type CMM or this is the probing system. So today we will be talking about the constructions and type of things, type of CMMs. So today's agenda will be types of CMM and its constructions. So basically, we have four types of CMM. Now, these are the four types of CMM. Four types of CMM, and it will be better if I show you a diagram of it, so it will be more relatable. Otherwise, sometimes it's not get very comfy. Okay, so see, the four types are these. Uh, the first one is the bridge type CMM. Second one is your cantilever type. Third one is your gantry, and fourth one is your horizontal type. So these horizontal type are further of two type: plate type, side plate type, and your rails type. And the difference is very subtle. I can tell you straight from this, like this is your rail type. This entire horizontal post, which is sliding back and front, is slipping on a rail. Fine. So this is called rail type. Instead, in some cases, there will be a flat plate on which this entire system will be mounted and it will be fixed. So that will become your side plate type. So we will see, like for the like as we will proceed, we will see. So for now, it will be better if you understand. This is the bridge type. So I like this is just a schematic diagram. So I like the schematic is just for sake of it. I will also be showing you the real pictures of CMM, what we use it commercially. Okay, so like let's start with the bridge type CMM. So I might be having the pictures of it. Let me put it up. Yeah, fine. So see, this is your bridge type CMM. Now, this is a very common type of CMM. In fact, this is the workhorse of your CMM. 90% or 95% of your this is bridge type. Now, why it is called bridge type? Now, let's start with this is the most common type. Most common type. And almost 95% of CMM what are available commercially are this only. Bridge type. Now, like this is very accurate, very accurate. In fact, it is most accurate in all the four type, very accurate, or you can say highest accurate, highest accurate. Now, it is called bridge type because this looks like a bridge. Now, as I was telling in last class, so if you will remember, if this is the front of machine, if this is your front, so the machine coordinate system from front to back is your y-axis. From front to back is your y-axis, y positive. Z-axis is along your tool movement. Along the movement of tool is your z-axis. some color I have to change here. So yeah, so your z axis is along the tool movement direction, and perpendicular to these two is your x direction. So from this to this, and here this side, from this bar to this bar and to this is your x direction. So this is actually bridge. This thing is called as bridge. This one thing, and then this, and then this. So you have this tool or this probing system. This was your probing system. So this is along ram axis also. This is also called as ram axis. So this tool is on the ram axis, and this looks like a bridge. So this bridge support is known as, it is looking like bridge, so it is called as bridge type CMM. Nothing so fancy about it. So it is having two-sided support. Two-side support is present. Now you must be seeing this is very thick and this is very like very thin. If you see the column cross section, then this is larger. So this is called a dominant side. This is called your dominant side, and this is called as slave type. Slave type. So what happens in reality, that this slave type is not attached. This is not attached. This is not attached to the structure. In fact, it is floating. And this is floating in air. Like suppose if the column come to a height and below is the machine structure, so there is some gap. And this is actually air bearings. Air bearings are used on the slave side and it can move freely without any friction. So if someone is asking you where are the air bearing used or what type of bearings are used in the CMM, they are air bearing. And the reason being, now this air bearing are also of two type. I will tell you this in a little bit more detail. These air bearings are of two types in general. One is your aerostatic bearing and another one is your aerodynamic bearings. So in aerostatic bearings, what happens? You need one external source to create pressure in air for air cushion. Now, as I was discussing above, here is your slave side. So this is not touching with the machine structure. So there is a film of fluid in this, and that film of fluid, which acts as a cushioning thing, is provided externally by compressors. Now there can be many problems with this. Suppose if your like your compressor, while supplying air, is not very like the temperature is not maintained, then that high temperature of air will cause the structure to deform. Like that temperature gradient, what it will form, that temperature gradient will make everything elongate. As you know that the thermal coefficient, the metals will expand in length, the length will change, and then that might cause trouble. So the cooling of this air is necessary. Also, if it is not dehumidified, then that air like can corrode the rails, or the machining structure over this column is sliding, that might get damaged. So there are many care to be taken for this, but that we will again read in the next chapter where we will be talking about inaccuracy. I'm just introducing it right now. And then second type, there is aerodynamic bearing. In this, you don't like no external sources are used. Instead, your motion is used to pressurized the enclosed fluid, and this fluid is your air. Okay, so this, I guess you must have read in machine design of bearings, where like hydrodynamic, hydrostatic, different type of bearing. On the very similar lines, these air bearings are also defined as aerostatic bearings and aerodynamic bearings. There is no such difference into it. And a combination of these two are also sometimes used, which are called as hybrid things. A combination of these two are known as hybrid bearings, are called as hybrid. So these hybrid air bearings. So these hybrid air bearings use the combination of both the two. So how do they do? Combination of aerostatic plus aerodynamic. So this actually at lower speeds, hybrid, at lower speeds, the static principle is used, where you supply one external, you use an external source to like provide the pressurized gas, and at higher speeds, the aerostatic principle is used, dynamic principle, where you capture an amount of fluid, and then you like just by motion you create a wedge, pressurize it under an enclosed area. So then that area, that part is only, that principle is generally used, dynamic principle. So now why do we use these air bearings? Now the reason is that these are very accurate. The reason for air bearings that there is no friction, so very smooth movement is there. So smooth movement. Now when I say smooth movement, then you can very well understand that there will be no vibration. So when there will be no vibrations, then the probe tip will also not vibrate. If it is vibrating, then the you can understand that the coordinate measured will not be very accurate. So this air bearings will eliminate the reason of such vibrations. Second thing, the movement is very quick. Like whenever you need any precise movement, then your air bearings are the best options. Bearings are the best options. Now these are the two major reasons for it. And then there is no wear and tear, repeatability is good. Those things are also, you can always add to it. So that is the logic why do we use air bearings in it. Fine. Now we will be seeing the next type of CMM, which is your cantilever type. I will be showing you the picture of it. So this is your cantilever type. Cantilever type CMM. And you can very well understand why it is called cantilever, because this looks like a cantilever beam. It is mounted on a very this column which can slide back and front. This is your front, this is your back. This arm can move left and right, or in the plus or minus x direction, and this direction is called plus or minus z direction, or the ramming axis. Okay, now this is a very small type of CMM, very small in size, so it is very portable. Fine, very portable. Then it is very good for shop floors. This is one point. Second point is your good for shop floors. If you need small components, then you very well you can measure with it. Then you can see like the operator can assess the job from all the three sides: one side, second side, and third side. So from all the sides, the accessibility of the job is very easy. So it's very dynamic, or you can say flexible for operators. They will happily go, and then they will take care of the job. They will see whether the probing system contact is very well or not. If it is not, then they can adjust the measuring system a little bit. But the some issues are there with this. Like, what are the issues? So that should be like your disadvantage. So your disadvantage number one is that it is like less accurate, less accurate, less accurate in comparison to your bridge type. And the reason is very simple. You can see that this cantilever, and then there will be a probing system down here from the tip. So of course, when it will move front and back, then the probing system vibrations will be high. Also, if the probing system is having some good weight, it is having some decent weight, so that will deform the structure a little bit. With time, this thing will bend towards the machine structure, and then the like over a period of time, then the measurements what will be given by this machine will not be very reliable, or even the repeatability becomes an issue. Like today, suppose in January you are measuring a component, some dimension is coming, and by December you are coming to check the same component, because in big companies, or in big sectors, what like the movement rate is not very high. It might become that the same product might come after 6 months or 7 months for the rechecking or verification, and in that case it will show some deviation. So such deviations are to be taken care of while using these cantilevers type of CMM. So these are relatively less accurate when compared with the bridge type. Then the third type is your gantry. Now you can see this gantry. This is your gantry CMM, and this CM is very like, I personally love it. If you will go in some big, this is called gantry CMM. This is like an elephant. So your first bridge was workhorse, like 90%, mostly commonly used. This gantry CMM is elephant. Why elephant? See, there will be these columns, and sometimes there will be four, sometimes there will be six, sometimes there can even be eight number of things. So these are huge systems, and they are generally made custom, like custom made. If you are setting up a industry and you want a CMM, you will have to establish a special infrastructure for it, special building for this, where the company people will come, they will lay down the foundation. Here foundations are laid, foundation, an entire big machine will be set up. This is very big, huge system, elephant. But it is having some added advantage to it. And what are those advantages? That suppose if you are putting a job over here, like of course you can understand that the job size what we can put in here will be very big. Any job whatever you will put will be very big. So bigger jobs can be catered, like it is good for bigger jobs. Then all the sides, the operator can stand and he can do the work. Like suppose operator will go and he will happily stand, and if in case he will touch the thing, he can see whether the probe is doing the contact or not, so he can very well take care of the inspection going on. So accessibility is very nice, is very flexible, I should say. But those things are there. Then suppose um, some very heavy parts are coming, good for heavy parts. So these heavy parts, suppose some 1000 kg, 100 kg something is coming, You cannot place it on bridge type, because if you remember, then there on bridge there is a machine structure. I'll show you again here. See, if you are placing this 100 kg job over here, for this first you will need one forklift. The forklift will come and it will raise and it will place here. And generally, like in next chapter also, I will be telling you that how even minute amount of dust, vibration, things can disturb this entire system. So in such case, you just imagine a big forklift coming and trying to raise the like 100 or 1000 kg job piece and trying to keep on it. It will be very difficult. And then a very heavy job piece, if it is kept on such a high pedestal, then that weight of the job might cause the deformation in this machine structure. And then again, the inspection process will not be yielding you very correct results. So that is one problem with this bridge type CMM. But in gantry, no such issue is there. A big forklift can come, it will drop this big 1000 kg thing, and as there is no machine foundation, like machine, this structure is not there, so it will not be deforming the probing system, and the measurements what will be obtained will be very accurate. So if you, in this, the problem of accuracy I will discuss. Suppose if there is a small job, then for small jobs this will not be very accurate, not a good option. And the reason is very simple, that suppose if there is a very small job, then this big system will have its own inertia. So wherever you will want to stop the system in machine coordinate system, suppose you are putting some coordinate, it might not stop there. Then second thing is, such a big system will have big huge driving system, big motors, big, everything will be very high powered. So of course the vibration induced by these things will be large, and the dimensions for a very good, very small jobs will not be very good. But whereas suppose you want to measure the dimension of a big thing, big job, big job can be your wings of some, this is your wings of airplane. So such a big wing, you cannot, first of all, the size in bridge is, for this bridge is good, okay, bridge. So first of all, the table size of bridge will be very less. You cannot place this entire wing in here. Second, the weight will be very high. In such cases, this gantry will act very dynamic. You can directly place in here and happily take the measurements. Okay, now the disadvantage with gantry is its size only. Suppose if you want to move bridge type, you can use some, in 2 days you can move from one place to another. But for gantry, it is not actually portable at all. You cannot move it anywhere. So the disadvantage of gantry is its size. You cannot move it. Then second one is its price. Very costly affair. To set up this big one gantry CMM, it will take in crores, like minimum 10 crore is not a very big amount, because according to this, the size of machine, the like the environment temperature has to be controlled, dust level has to be controlled, so the price will go very high. So it's not like, these are some disadvantage of it. Then comes the last one, which is your horizontal type of CMM. So in horizontal type of CMM, there are two types. One is your plate type and one is your rail type, which I told you. Just let me put, yes, this I am putting the, yeah, this is your horizontal type of CMM. Now, this is the only CMM in which the probe is attached to the moving post. Fine. In this, the probe is fixed on the horizontal y-axis instead of vertical mounted on a ram axis, z-axis. Sometimes people get confused it with your cantilever, but please don't get confused. It is like some difference is there. This can move front and back. This is your front and back. This can move. This is your y-axis. Sorry, this is your x-axis, this is your y-axis, and this is your z-axis. So till now you might have seen that this z-axis to be from ramming axis, but it is not so in this case. So in this, there are few advantages. First we'll talk about advantage. Advantages in this, the moving mass are quite less. Moving mass is quite less. So scanning speed is very high. Fine. Now, and these, you can see these systems, these are very lightweight. So they can very easily move front and back. So the scanning speed of this entire job will be very, very quick. Fine. Now in this, the disadvantage part also we will discuss. And the disadvantage is that this is the least accurate. Till now, whatever we have studied of all the four types, this is the least accurate system. But it is very good for thin-walled structures. And such thin-walled structures are mostly used for automobile sectors. You can understand that in automobile sector you need to increase the manufacturing rate. So in such manufacturing rate, the measurement is also a part of it, and the measurement scanning speed is very high in this, so that is also an advantage for this. And second, it is giving you very decent result for the thin walled structures, like the chassis of your car. It will be very nicely scanned by this, so this is ideal for in such cases. Fine. And in fact, if you go to Maruti Pune or any other places, you will see such type of system working. So, like, out of all the four, whatever we have talked, this is the most least accurate, but very quick. So it is very dynamically used. And the other, out of other three types, the most accurate is your bridge type, but it is for medium to small jobs. If you go for the higher, heavier jobs, then the gantry is the best option. Okay, so till now, whatever we have discussed, those are the types of your CMM. Now, in whatever be the type of CMM, now we will be studying about the structures of it. The structure of CMM. Now, what is the difference? I will tell you the difference. Now, till now, whatever we have studied, in all the four types, few things were common. And what were those things? Now, all your systems, all the CMM systems, all the CMM types, I should write, we're having four common parts. Number one was your machine structure. This part, this is your machine structure. This thing, fine, this is number one. Second one was your computer hardware and software. Now this segment, computer hardware and segment hardware part, is like already we have discussed last day. Like it deals with the like the form fitting part and all those things. Okay. Third one is your linear measurement transducers. Linear measurement transducers. And fourth one, the most important one, this is your most important part. And even being the most important, it is very delicate also. and it is responsible for maximum errors, and that part is called your probing system. Probing system. So just see the schematic of it. This is the machine structure. Like on this machine structures, you will be placing jobs. Okay. Then this is the computer hardware part where you will be putting the different things, different putting the input to move the machine, and whatever coordinate what will be measured by this probing system attached to the head of it, that data will also be sent to it, and the software in it will be responsible to do all the adjustment or the form fitting part. These movements of all the components, whether that be in this thing or whether that be in machine coordinate system or in part coordinate system, that is taken care by the linear measurement transducers. Okay, so these are the four things which will be common in any type of CMM, whether that be bridge, whether that be your horizontal type, whether that be your gantry, whether type, whatever be the type, four type what we have studied above, these four things will be common throughout. So now it is our responsibility to know one by one all the areas. Okay. So the first part is your machine structures part. Number one is machine structure. Now, what will be the desired properties of it? You can very well guess desired props. First one will be, it should be your vibration insensitive. Actually, this is wrong. It should be insensitive to vibrations. Or vibration resistant, should I write? Okay, you must get the idea. So like suppose if there is some vibration going on near your CMM, suppose there is some vibrations going on, so this machine structure should not happily transmit it. Okay, so whenever such vibration damping characteristic of any material is discussed, the first material which might come in your mind is your cast iron. And yes, cast iron is used over here. It is a correct answer. But cast iron was used earlier. Nowadays, we are not using cast iron. The reason I will tell you that this is very heavy, and the period of time this will become very dirty. Okay, so this cast iron generally we nowadays we don't use. In fact, nowadays we use granites. Now, even in granites, there are two different types. I will write the name. It is not needed to remember, but as I know, I will write. Okay, one is Dabros and second one is Gabbro. So these are actually mined in Sweden and South Africa, and they are highly used nowadays in all the CNC machines, in all the CMM machines. These are highly used. Why it is used? Because of two reasons. One, the K, KU 3.5 watt per meter Kelvin. This K is actually your thermal conductivity, and alpha, which is your linear expansion coefficient. It is also very less per Kelvin. So suppose if there is some temperature gradient, it is very low. And second one is your the expansion change in length of the machine structure because of temperature change will also be very less because this alpha is very less. Okay, but this thermal conductivity, low value of thermal conductivity is only creating the trouble for this. Like what is limiting us from using these granites most often is this low value of thermal conductivity. Why? That suppose if as thermal conductivity is low, so what happens if there is one component, this is your granite, okay. Now at this point there is some temperature rise. So the heat will not be transmitting to the other parts of area. So here the temperature will increase, and here the temperature will be less. Fine, because this K is very less, so the conduction of heat in this machine structure will take very slowly. So in this part, if the heat accumulation will start taking place, so it will manifest in terms of internal energy, so the temperature will increase. So even if the alpha value is quite less, still there will be some change in length, and here the change in length will be less. So this uneven expansion will cause deformation of machine bed. Fine. So we generally use this in controlled conditions. So this is very important. You can use ceramics, you can use granites, and it is mostly used also nowadays, but we try to keep the conditions very controlled. Otherwise, because of this low K and very low alpha, uneven temperature will come and the structure will deform. So that is its trouble. So nowadays we are using another options also. What can be another options? Like how can you take care of this? Like this uneven expansion, how can you take care of it? You can take care by increasing the value of K. Now, unfortunately, even if you increase the value of K, the alpha will also increase. Like one option, like for to avoid this deformation is to conduct the heat. That you can understand. But to conduct the heat, you need to increase the value of K. But for the materials in which the value of K is high, the alpha, which is your linear expansion coefficient, is also high. But this alpha can be adjusted. Can be adjusted. Suppose there is some temperature given to it, the length will increase throughout. So then that is not a problem, because if the length is increased or changed very quickly, you can adjust this numerically by computers. You will add some correctional value to it and then it can be adjusted. So this can be adjusted, so we are not so much worried. And this K was important because always it is not possible to do this controlled conditions, not always possible. So a very good option nowadays, what we are trying to explore is aluminum. Now it is a very surprising choice. Like in many times in interview, people ask that can aluminum be used as machine structures? So people will first say no because of this alpha value that deformations will very be high. But you should also know that this can be adjusted. So nowadays aluminum are also used. So another options are ceramic and ceramics. Ceramics are also nowadays used. Then we are also use your some carbon fiber like Invar and carbon fibers are also used. Invar or carbon fibers. So these are the materials and the expected properties. Fine. Now the second part. Second part was our linear transducer systems. What I wrote earlier, let me see. Okay, computer hardware and software part. Okay. So this computer hardware and software. So this is having, we will not be studying this in too much of detail because what software do we use and how are they doing, I already told you about this. Fine. That different algorithms what we use in here, and then those informations I have already given you. But there are some other things also what it does. Like it controls the machine motion. This already I have discussed, like in machine coordinate system and part coordinate system. Those things are determined by this. Second thing is you like the alignment of part coordinate system and machine coordinate system, that is also taken care by this computer hardware thing or the software part. Then if any corrections are to be made, it makes corrections. Now what corrections? Makes corrections. What corrections? So there are many, but today I will be telling you one, and the other types of corrections we will be discussing in next class. Like where the inaccuracy part will come, like what all can add to the inaccuracy of the machine. There I will tell you how to correct it, and then at that point of time I will tell you. But today there is one term which is called as cosine error. What is this? This I will be teaching you in probing system, but that can be adjusted by this computer software part only. Okay, then it will do all the calculations. Calculations of what? Calculations, when I say, I mean the form fitting calculations. Form fitting calculations. Like the relation between how to make the substitute things and actually. And then at last, it will do the comparison also. Comparison between substitute and what? Actual or nominal? Tell me. Think on it. Yes, you're correct. It's nominal. And then the report part can also be made. Comparison between these two and whatever be the error or deviations, those parts will be taken care by it. So the second part, which was the computer system, handle these things. Then there is the third part, which will be your linear inducer, linear measurement transducers. The third one was linear measurement transducers. So its aim is like the main reason why we use it to give the feedback. Reason is to use, like suppose in computer system, in computer, you put the value of suppose 1 meter for machine coordinate system to move. Now, which system will move it to 1 meter? That is taken by linear measurement transducers. So this it is working with, it actually provides a position feedback. Provides a position feedback within the working range. Fine, you can understand this. Suppose whatever be the measurement what you will be asking the computer to move the machine coordinate system, it will be taken care by the linear measurement transducers. And like whether it has reached to that location or not, such feedback are sent back to the system by these measurement transducers. Now it works along with some encoders. Encoders are used. Now, what are encoders? Encoders are a type of transducers which will change displacement as electronic signals. They convert this, converts, convert change in displacement or motion also, you can say motion to electronic signals, and these electronic signals are again given back to the system to do the possible corrections. Now there is something also in linear transducer, and those things are called scales or photoelectric readers. Now what are these scales? Now when you said move 1 meter, so that 1 meter has to be compared with some known length, and that known length with which it is compared are scales. So the material for these scales are again either you, like earlier time it was steel things was used, but you can very well understand that in steel that the with temperature the deformation is very high. So glass ceramics are used nowadays. Glass ceramic, and a very common material is zero. Zeroda. And why this Zeroda is used, you can remember this. Fine. This is a very important material. The beauty of this material is alpha is so less, I can't even tell you. It's 0.05 into 10 to the power minus 6 per Kelvin. So this is almost equal to zero. So there is no change in length with temperature variations. So these glass ceramics, wherever you want to use such type of thing, where temperature, with high temperature, the length should be very less, you can use Zeroda. And it is very commonly used, but like very costly also. So yeah, you can do this, and photoelectric use readers also you can understand. So these linear measurement transducer take care of the movement, and these things are there in it. Now we will come back to the fourth and most important part of these structures, which is probing system. Now this probing system is actually made up of three parts. One is your probe head, three parts. First part is your probe head. Second part is your probe itself. And third part is your stylus. Okay, now I will be showing you diagrams, then only you can understand the difference. Otherwise, in general, people call this probing system as probe. They will not be like breaking down it into further small things. They will say it is the probe itself. But like as I have some experience, so I'll be showing you some diagrams, and then you can very well understand what is the difference. Okay, so let me show you a few diagrams of this. Yes, this can be one. Then another one will be this. Yeah, first you see this. In this, you can very well see that these are the heads. These are the probe heads. These are the probe heads. Fine. These are the probe heads. This attachment is called probe. Okay, it's written also. This is called probe head. This part. This part is attached to the ram axis. Ram axis. This is called probe head, shaded part. This from here to here is called probe, and the tip of this probe is called stylus. Okay, now it's very simple, by which you can understand. As per function, this entire thing will function together. So you cannot like going into very minute details of how probe, what is stylus. That stylus part we will go, but in very detail, this probe can be very happily be eliminated. Similarly, the probe head, but you should understand that the actual probe head is attached to the ram axis. Now, this stylus can be of different shapes. You can see this is mushroom type. It is multiple probe. This is also multi probe. This is your cylinder, the disc type. This is your ball type. This is your pencil type. These three are ball type, and this is your pencil type. Pencil type. This is your mushroom type. These are multi. So these are the stylus. Fine. These are the stylus. And this probe and stylus together, I can show you another image for this. See, yeah. Now you can very well see this is the probe actually. This entire thing is your probe. And then this tip part from here to here, it's stylus. Okay, so in probe you can see there are alignment marks. There are different C-spanner to open this thing, probe body. Now this you can understand, but if I will be explaining you this, it will be overkill, and we should not be aiming to kill a chicken with a cannon. Okay, so for our studies, you can just understand this was your probe head. This was your probe head. To this probe head, such probes are added, on tip of which there is stylus, and these things contact the job. these stylus contact the job, and then these points will touch the job, and the feedback is sent to computer system, and coordinates are measured. Then coordinate, and then these coordinates are filled with form filled, then substitute, then comparison, then result. Okay, so I guess you understand the logic now. Fine. Now we will be discussing this little bit in detail. What we will do, that these probes can be of two types. Like the probing system can be of two types. First type is your contact probe. Contact probes. And second one is non-contact probes. Whatever I have shown you above, they all were the contact type of probes, because they all will touch it, and then depending on the touch or the tactile, these contact probes are also called as tactile probes. Tactile probes. Tactile means to touch. So these probes will touch the job and then will give you back the feedback. So in this tactile things also, there are two types, in fact three types I will tell you. Why this is needed? Because you should know. One is your hard or fixed type. Second one will be the touch trigger type. And the third one is your analog scanning type. All the three we will discuss one by one in detail. And in non-contact probes, there are also three types, but two most common type I will tell you. And in these types, one is your laser type, and second one is your vision probes. They will not be making any contact. By the name itself, you can understand the laser type. A laser will be dropped on the job, and then the dot or the laser dot on the job will be read by triangulation, and then the coordinate will be estimated. Okay, so these non-contact probes we will be also seeing two types in detail next. But first we will see this hard or fixed type. So just they are just the definitions I will tell you. In this hard or fixed type, what is done actually, that if suppose there is a job and there is a probe, so your operator, this you can remember it as by operator dependent. Yes. So what will be done, that the operator will move this probe till it touches this job. It has to be like operated by the operator itself. Machine not has to do it. So the operator will move it till the moment it will touch this. Once it is touching, the operator will give the feedback to the machine that yes, contact has been done. Then it will be shifted to some this direction. Another point will be contacted. Again, the operator will only take care that okay, now the contact has taken place, so it will be moved to next point. So these operators will measure the machines, measure the coordinates. So the drawback of this is that every operator will be having different style. Okay, like some, the experts will be just touching it and moving it, touching at another point, then moving to another point. Now with these, what is the trouble coming, that suppose if this material is not very rigid, suppose it is some rubber material, so if the pressure between this and this is increased, then the deformation will happen, and that the coordinate what will be read will be slightly erroneous. So when operator dependency is there, then such error chances are present. Fine. In touch trigger, this is entirely machine operated. In this, the machine will itself optimize its pressure. Optimize its pressure. So when machine is optimizing its pressure, then there is no such issue of like such deformation. Even by the same, like suppose if the material is deforming throughout, so the same pressure is given, then the deformation will also happen similarly, and the form whatever will be fit will be actually just parallel to the original surface. And if it is throughout parallel, then it can be arithmetically adjusted by computer by some few mm, and that can be adjusted. So it's in this, the advantage is that pressure remains constant. Now this pressure remaining constant is very important when there is a turn. Suppose there is job coming and then turning like this. Now the probe at this point has to touch it here, then touch it here, then touch it here, then touch it here, then touch it here, touch it here, touch it here. So the machine will take care of this very nicely, whereas with humans the chances of error will be high. So this touch trigger probes are quite giving you better results. Okay, then the third one is your analog scanning type. In this, the scanning is continuous. Scanning is continuous. It is very similar to trace a line with your finger. You take your finger and then suppose there is a line, this is your finger, right? And then you move it across the line. So the way you are tracing this line, or you are like feeling it, that okay fine, this is the line, and you will be giving like a feedback will be given to your brain. Similarly, a probe will be kept on the job, and the probe will move, and it will continuously scan it. It is very fast method, but you can very well understand that if this is very fast, so the amount of data what it will acquire will also be very high. So the processing power needed for such systems will be very high. Very fast method. So data will be your processing power should be high. Second thing, as the probe is in continuous contact, so the wear of probe also is very large. Fine. Like a probe, you just imagine it is continuously being dragged along the surface, so the uh, wear will be very high. Now coming to your non-contact probing systems. In non-contact probing system, first one was your laser. So laser type of probes. So in this laser type of probe, what we do, that a laser beam is focused on the job. Suppose this is the job, we take a laser, you focus it here, so there will be some mark, and then this will be triangulated by some another peripheral systems, which will say that okay fine, here is the laser mark dropping. So then they will estimate the distance from this, and then the coordinate will be measured. So there will be no contact between the actual contact between the probe, because there is no probe, actually it's only a light which is falling on the surface. Okay, so a laser beam is focused on the job, and its position is read by triangulation. Job and position is read by the triangulation. through a lens in probe receptors. Now, you can very well understand that the method of this scanning will be very high. Like the scanning speed is around 300% higher, very quick. Then second thing is, as no probe is present, so probe wear is equal to 0. Then what else? It is very good for rough surface. Fine. So those things can be understood. And then there is second type, which are the vision probes. Now, in vision probes, what we do, that we use a very high speed. In this, what we do, a camera is used, and it generates a multitude of measurement points within a single video frame. Cameras are used. Just understand this thing. Camera are used, and then the picture is taken. Camera is used, picture is taken, and then this picture is electronically digitized. Digital, and then the like this digitized picture is compared with the uh, already calibrated image which is already present. So like we should not talk much about this, but just for the idea you should know. Okay, now this is in the non-contact probes. Now little bit more discussion we should do in these two areas. In tactile, two other things what we should understand is that this touch trigger and the probe itself, like how the probes are made. Like these are the probing system, right? So in probing system, there was one tactile and there was non-tactile. Non-tactile, just an idea I have given. I have not discussed in very detail because it completely goes in the purview of electronical persons, like image processing, all those area are in this, which is not area of interest to mechanical engineers. So I'm not touching it at all. Now, in tactile contacts, tactile probes, there are three types: hard or fixed, touch trigger types, and this is what we mostly use because we are also not very much happy when the operators are like any reading which is operator dependent, we try to avoid it. So we use touch trigger type of probes, and analog scanning is also done. It is very good for your turbine blades or any aerofoil, very complicated smooth blade profile if you want to have, then analog scanning is the best thing. But in this again, your this processing power is very high, amount of that is needed. So we'll be talking now about probe head. Fine. So this probe head, sorry, not the probe head, we will be talking about probe and stylus now, because probe head is again not a very interesting topic for us. Yeah. Now see, this part, this is called, this is the ball. Fine. This is your effective length. And this entire is the total length, overall length. This entire thing, this L, whatever is given over here, is your effective working length. Effective working length. Now this you can understand, over here there will be one screw to, so such that this entire thing can be attached to your probe head. Okay, so in this probe head, this is your screw type. It varies from M to M6, not very important to know. Then this ball is made up of ruby. This is important, you should know. It is made up of ruby. Ruby is one of the hardest material known to us. By the way, this is artificially made, not pure ruby. We make it artificially synthesized. So it is having very high compression strength and very high resistance to mechanical corrosions. But suppose you want to do the continuous contact scanning, then it is not used in only case of aluminum. Okay, it is very high compression strength and very high resistance mechanical corrosion, but not used for continuous scanning of aluminum. Not used for continuous scanning of aluminum, because this a form of it, a buildup of aluminum forms on the surface onto the ball. Like when there is a ball, and on this, when you are doing aluminum, then a part will stick to it. A buildup will take place to do this continuous scanning. So we generally don't use it for aluminum. So for aluminums, we use your nitride balls. Fine. So silicon nitride mostly. Silicon nitride balls. So these balls are used instead of ruby. So these are the types or the material. Again, this is made up of steel, by the way. This part is made up of steel. And when the probe size is very large, then it is made up of ceramic. Ceramic for higher D, large D of balls. Then ceramic you use. Okay, so this is the basic construction of it. Now there is something called as one small error about this balls we will talk about. Errors related to this ball diameter. Now suppose there is a object and it is being touched by the probe. So which point will be taken as coordinate? This point or the center of your ball? It's a very good, like it's a very common question to be understood. Like suppose if the ball is making contact with the object, then it will send some feedback to the machine, and this feedback will be your coordinate. So this coordinate will be of which part? This or the center of the ball? Actually, it is sending the center coordinate. But in reality, it should be this point. So there has to be the radius compensation. Radius compensation. So feedback to machine in terms of coordinate is given for center, but it has to be given for the object. So in order to do that, the radius of this ball has to be compensated, and that is called your radius compensation. Now the issue is that this radius compensation should be done in which direction? The question is, this radius compensation, I will write this as RC be done in which direction? Now why this direction is important? because now it is very easy for you to understand that okay, fine, this is the radius, but the object profile may not always be such so simple. Suppose your object is this, okay, and then your ball is sometime touching it here like this, sometime ball is touching it like this, sometime ball is touching it like this, sometime ball is touching it like this. So this is the object and this is your coordinate system. So this is your coordinate system. Of course, this is your machine coordinate system, and your probe is touching this every time, and some radius has to be compensated. So now you can very well see that this radius, whatever has to be compensated, it has to be compensated in the direction parallel to the normal of the work at every point. At this point, the normal to this body will be along this. This is normal to body. This is your body, okay? So, so normal to body direction, if you are compensating, then only you can get the radius. At this point also, the direction of normal will be this way. So this radius has to be compensated in the negative direction of your normal. Fine. But if in mistake you compensate this radius parallel to the machine coordinate axis, if the radius compensation be done parallel to machine coordinate system axis instead of negative normal direction, then of course you can understand there will be some error, and that error is called as cosine error. Fine. So this will come. It will, like, sometime it can be asked that what is the major cause of this cosine error. So it is wrong direction adjustment of radius. As simple as that. I can show you a pretty good drawing for this. See, this is the same thing what I was talking about. That suppose if this is the job, fine, this is the job, and this is your radius of ball. If you adjust the radius parallel to this axis, which is, you can understand it is wrong, so then the error what you will get will be your cosine error. Okay, so today's learning we will just recap for a while that what all we have read till now. So today's class was entirely based on the structures part. We saw different types of CMM. We saw, like, there were 4 types: bridge type, gantry type, cantilever type, fine, horizontal type. Then we saw the structure. In all the 4 types, these structures were common. This was also 4 types. Those was your probing system, machine structure, then your computer system, and the linear transducers. Probing was the most important. We studied about probing in detail, and in probing, only one type of error what we discussed today was that was your cosine error. Okay, and these cosine errors are adjusted by your computer systems. So this can be adjusted. The hardware or the machine structures, different material and all we saw. Okay, so with this today we'll be closing it. In the next class we will see all other methods by which the error can seep into our measurements, and then we will be closing the thing. Fine. So till then, thank you. See you guys. And yes, you can like, share, and subscribe. Press the bell icon to stay updated. So thank you. See you guys.